Hi again, I'm Mrs. Burns and welcome to lesson 8 of our fractions section. Today we are talking about 6.6 and we're going to be applying the order of operations to our fraction problems. And part of the order of operations we need to remember is this whole idea of BEDMAS. What does BEDMAS stand for? Well, the first one is brackets. Then we'll look at exponents. After that we look at division. And then multiplication. Now the division and multiplication can be in either order. We just want to go from left to right. And then addition and subtraction are last. And again, these can be in either order as long as they go from left to right. So this is our order of operations we need to consider in all of our fraction problems. So let's look at our first example. We see that 5/6 minus 1/3 times 3/4. Whoa, which one do we do first? Well, the first step is to see, oh, we have multiplication. Multiplication always trumps addition and subtraction. So we'll say 5/6 minus 1/3 times 3/4. So 1 times 3 5/6 minus 1 times 3 is 3. 3 times 4 is 12. Now that we're into our subtraction section, we need to remember that we have to make sure the denominators are the same. So 6 times 2 equals 12, and if we multiply 6 at the bottom times 2, then we need to multiply 5, the numerator, by 2 as well. So we can rewrite this as 10 over 12 minus 3 over 12. 10 minus 3 is 7 over 12. Can we reduce this any further? No, we cannot, so this is our answer. Let's look at B. 3½ divided by 3/4 minus 1½ plus 5/6. Well, first step is our fraction section, and we also need to make sure all of our mixed numbers are written as improper fractions. So I'm going to do kind of both of those at the same time, just to save some space. So 3 times 2 plus 1, 6 plus 1 is 7 over 2 divided by 3/4 minus, now this is our bracket section, 2 times 1 is 2 plus 3, plus 1 is 3 over 2 plus 5/6. Okay, so one of our rules with addition and subtraction is that the denominators need to be the same. So these two need to be multiplied by 3. We can rewrite this as 7 over 2 divided by 3/4 minus 9 over 6 plus 5 over 6. So 9 plus 5 is 14 divided by 6. So now we need to decide what's next, the division or the subtraction. Well, according to BEDMAS, division comes first. So 7 over 2, remember we can flip this guy upside down and multiply by the reciprocal. So 7 over 2 times 4 over 3 minus 14 over 6 can be rewritten as 7 times 4 is 28, 2 times 3 is 6, minus 14 over 6. Now we have subtraction. Are the denominators the same? Yes, they are. So we have 14 over 6. Can this be reduced? Yes, they can. We end up with 7 over 3. We could also write this as 2 1/3. Either one. All right, C. Look, we have brackets. 12 minus 8. This is 4. So 3/4. Anytime you see something right next to a bracket, it just means that you're going to multiply that. We can also write 4 as a secret fraction. We're going to do all of our multiplying first before the subtracting. So 12 over 4 minus 3 over 8. Now, are the denominators the same? No, they're not. So we need to multiply both of these to make the denominators the same. 24 over 8 minus 3 over 8. 24 minus 3 is 21 over 8. Can we make this any more reduced? No, but we can express it as a mixed fraction. There you go. All right, on to D. 3 divided by 3/4. Oh, that's division. Then we have then we have addition. Then we have multiplication. So we can do each of those lined parts at the same time and then add them together last. So 3 can be written as 3/1. Divided by 3/4 can be written as multiplied by 4/3. Plus, we've got 5 can be written as a fraction times 1/2. So 3 times 4 is 12, divided by 1 times 3 is 3, plus 5/2. Are the denominators here the same? No, they're not, so we can make them both. I think the lowest here would be 6. So 12 times 2 is 24/6, plus 5 times 3 is 15/6. 24 plus 15, we get 39/6. Can this be reduced? Nope, but we can express it as a mixed number. 6 goes into 39 6 times, so with 3 left over. Keep the denominator 6, but hey, look at your fraction here, 3/6, that can be reduced. Let's divide both here by 3, and we end up with 6 and 1/2. So you can write it either of those two ways. All right, so we have 2/3 plus 1/6 times 1 2/3. First step is to multiply this and change this mixed number to an improper fraction. So we have 2/3 plus 1/6 times 3 times 1 is 3 plus 2 is 5/3. Now we can say 2/3 plus 1 times 5 is 5. 6 times 3 is 18. And now we need to look at the denominators for addition. 3 and 18 are not the same, but can 3 go into 18? Yes, it can. It goes into 18 6 times. So 2 times 6 is 12/18 plus 5/18. 12 plus 5 is 17/18. Can that be reduced any further? No, it cannot. Okay, last but not least, all of these are mixed numbers, so we need to change these to improper fractions. So 3 times 10 is 30, plus 7 is 37/10, divided by, and this part is in brackets, so this is what we'll do first. 1 times 10 is 10, plus 3 is 13/10, plus 1 times 10 is 10, plus 9 is 19/10. So 37/10 divided by 19 plus 13 is 32/10. We can flip and multiply by the reciprocal. 37/10 times 10/32, and we end up with 37/32, or you can say this is a mixed fraction. 32 goes into 37 one time with 5 left over the same denominator. All right. On to our harder questions. Add one pair of brackets to the left side of each equation to make it true. So we have this huge equation, and we need to guess. Where do you think the brackets should be? So I'm just going to do guess and check, and if you get it wrong in the end and your answer does not equal 3, then you just go back and you try again somewhere else. So I'm going to guess, hey, I wonder if the brackets are here. Maybe I have to add 1/2 plus 5/8 before I do everything else. So let's try it. 2 needs to get changed to an 8 so that the denominators will be the same. So we have 4/8 plus 5/8 times 4/3 plus 3/2. So 5 plus 4 is 9/8 times 4/3 plus 3/2. Next we do the multiplying. 9 times 4 is 36. Divided by 8 times 3 is 24. Plus 3/2. We need to change that to 24. 36/24. 3 times 12 is 36/24. So we've got 72/24, and this can be reduced to 3. Hey, we're right, because the answer was 3. Hooray, that one's correct. Let's try the next one. All right, we've got some mixed numbers we need to change here as well. But let's guess, where should the brackets go in this equation to make it correct? Let's just guess there. And if it's right, hooray. If it's not, we'll just do it again. So 1 1/4 can be expressed as 4 times 1 plus 1 is 5/4 minus 1/8 divided by 3 over 2 minus 3/4. Okay, so 5 over 4 minus 1/8 divided by, these are not the same denominators. We need to change that first. So divided by 6 over 4 minus 3 over 4. This is the same as 6 minus 3 is 3. Keep the denominators the same. So 5 over 4 minus 1/8 divided by 3/4 is the same as saying 1/8 times 4 over 3. So we're going to focus on that part next because we multiply next. So 1 times 4 is 4. 8 times 3 is, 24. We can make 4 go into 24 6 times. So 5 times 6 is 30 over 24 minus 4 over 24 equals 30 minus 4 is 26 over 24. And this can also be expressed as 1 and 2 over 24 or 1 and 1/12. Hey, that's the same answer as here, so it was correct. Awesome, we put the brackets in the right place. All right, in the summer, Oscar earns $12 an hour as a cashier in a grocery store. One week, he worked 8 hours a day for 5 days. Of these days, one was a holiday, for which he earned time and a half. How much money did Oscar earn that week? So time and a half, let's define this for a second here. Time and a half means that he made $12 plus half of 12. So what's half of 12? 12 divided by 2, $12 plus 6. So half of 12 is 6. So he earned $18 for that one day, $18 an hour. So let's figure this out. We should look at the 4 days and then again at that one time and a half day. So he made $12 an hour times 8 hours a day times 4 days equals 12 times 8 times 4 equals, he made $384. Okay, but then on that 5th day, he earned time and a half. So he earned $18 an hour times 8 hours times 1 day equals 18 times 8 times 1 equals $144 that day. So let's add all those days together. So he earned 384 plus 144. So he earned a total of $528. Wow, Oscar, good summer job. All right, last question for today. One week, Bouquet spent half of her allowance downloading music, a quarter of her allowance on a t-shirt, and 1/8 of her allowance on bus fares. She had $5 of her allowance left at the end of the week. How much was her weekly allowance? So, if her weekly allowance is the whole, we can say that half went to music, and then that half was broken up into quarters, and a quarter went to clothes, and then that quarter was broken up into eighths, and this was for the bus. And we know that at the end she had $5 remaining, so that means that this remaining here must be $5. So one way that you can work this out would be backwards. Remember, we talked about ways that you can solve a problem. One of them is working backwards. So if 1/8 is $5, then she must have spent $5 on the bus. And if $5 and $5 goes into the quarter, then she must have spent $10 on a t-shirt. So 1/8 must be $5. That means 1/4 must be $10. That means 1/2 must be $20. And that means that 1 and a 1 must be $40. So Bouquet earns an allowance of $40 a week. Now for this last example, I want you to come to class thinking, is there another way that you can solve this not by working backwards? Well, that sums up all of our lessons for Chapter 6. Next day we're going to have a review day, so please prepare well and review any videos that you need to on Chapter 6, all of our lessons on fractions.